Hey everyone, Mr. Scullin here. We are back at it for lesson 4 in unit 5, and today we're going to be talking about adding and subtracting and multiplying some radical binomials, so two-term radicals. Let's jump right into it and get started here. So kind of ignore this. This is kind of in relation to number 2, but basically the reason we have this here is to remind you that if you have unlike radicals, you cannot add them. Unlike radicals equal no add. I guess I should put or subtract. Okay? So it's kind of like when you had fractions. So the rule with adding and subtracting is you have to have like radicals to add or subtract. Okay, so I make I use the analogy of adding fractions. So if you had a fourth plus 1/4, you have like denominators. You don't add those denominators together to put 8 here. You put a 4 here, and 1 plus 1 is 2, which makes 1/2. It's very similar here. If you have 7 to the 4th root of 5 minus 2 to the 3rd root of 5, okay, we can't add these together because they're not like radicals. Why are they not like radicals? Because you have a 3 here and you have a 4 here. We can't add those together. Now, if you had 7 4th root of 5 minus 2 4th root of 5, if these were both 4th roots, okay, basically what I think of is we have 7 of these, 2 of these. 7 minus 2 is going to give us 7 minus 2 would give us 5 4th roots of 5. And that would be our answer there. Okay? Over here, you'll notice that you have a radical 2 and you have a radical 3. Because these are not the same, okay, then you cannot add them. Now, you may be wondering, well, this is a 5 and this is a 5. Those are the same numbers. True, but the index is different. We can't add them. Here, we have square roots. They're both square roots, but this is a 2 and this is a 3. Those are not the same. So the index has to be the same, and the number underneath the symbol has to be the same for you to order to add or subtract. Now, if this one, let's just make one up here so that it works, so I can show you one that works. If I had 8 radical 2 plus 9 radical 2, then I would notice that my radical 2's are the same, and I can add the number out in front. 8 and 9 would give you 17 radical 2. Okay? So make sure you follow those rules and look carefully, especially when you have different indexes, because those are smaller print. You may miss them if you go too fast. All right, let's go to the next page here. So here are a couple examples. The first one's relatively painless, and the second one you got to do a little bit of simplifying first. So actually, why don't you go ahead and hit pause and try 3 and 4. See what you come up with. I'll give you a hint. On number 4, you're going to want to simplify the radical first. Okay? So go ahead and try 3, 4, and then hit play and see how you did. Okay, so again, if I see a plus sign, it means I'm adding, so I'm going to check my radicals. Radical 6, I'm good, so I can add the numbers in front. 5 and 3 gives me 8 radical 6, and that would be my answer. I can't simplify the 6. Now, some students will make a mistake on number 4. They'll say, oh, radical 50, radical 32, and radical 18, they're all different. I can't add them. I kind of gave you the hint here. You want to simplify first. So 50 breaks down into the square root of 25 and the square root of 2, which is 5 radical 2. 32 breaks down into 16 and 2. Square root of 16 times the square root of 2. Square root of 16 is 4 radical 2. This 3 out in front, you have to keep in consideration when you have this 4. So basically, the square root of 32 breaks down into 4 radical 2, but the 3 is out in front, and this is multiplication, so it's 3 times 4, which is going to be 12 radical 2. Same thing here. This is a 5 out in front, so whatever 18 breaks down into, you're going to have to multiply it by 5. So 18 breaks down into the square root of 9 times the square root of 2, which is 3 radical 2, and 5 times 3 is 15, so minus 15 radical 2. So you'll see now, you'll notice that I have radical 2, and radical 2. When you have adding and subtracting, you're always going to work left to right when you simplify. So 5 plus 12 is 17 radical 2 minus 15 radical 2, and that would be 2 radical 2 for my answer for number 4. Okay? All right, so now we're going to get into multiplying. All right, and off to the side, I'm going to give you just a quick review here. If you have radical 6 times radical 2, you can multiply those together to get radical 12, which breaks down into 2 radical 2. If you have radical 6 plus radical 2, that gives you nothing because these are unlike radicals. So make sure you understand the difference between multiplying with radicals and adding and subtracting with radicals because the rules are different and you can kind of get yourself crossed up if you're not careful. So this says multiplying radical binomials. Again, I have a subtraction sign here, so not to get confused with your exponent rules. You can't take this 2 and square it and square that. This means radical 2 minus radical 3 twice. And we're going to do some foiling, right? So radical 2 times radical 2 is radical 4, which is just plain old 2. Radical 2 times a negative radical 3 would be a minus radical 6. 2 times 3, 6. Negative radical 3 times radical 2 is going to be a negative radical 6. And negative radical 3 times negative radical 3 is a positive radical 9, which is just, not 9. Radical 3 times radical 3 is radical 9, which is just 3. And so you put your like terms together. 2 and positive 3 would make 5. Radical 6 and radical 6 would make 2 radical 6. Right? There's really like a 1. You can think of it as like a 1 in front of here. So you have negative 1 and negative 1 make negative 2 radical 6 answer. Okay? Go ahead and try number 6 on your own. Hit pause and see how you do, and we'll check back with you. Okay, here we go. 5 times 5, 25. 5 times negative radical 2 is negative 5 radical 2. You cannot times a term like an integer like 5 with a radical and make that. A lot of kids will do this wrong. 5 times radical 2 and try to tell me radical 10. You can't do that. Okay? If you just have a number times a radical, you just put it out in front like I did here. Radical 2 times 5 is a positive 5 radical 2. We always put the integer out in front. And then radical 2 times a negative radical 2 would be a negative radical 4. Radical 4 is just plain old 2. So 25 minus 2 is 23. Negative 5 radical 2, positive 5 radical 2. Those middle terms cross out. And we're just left with plain old 23. Okay? Moving on. So on the back here, we've done some stuff like this before in your Algebra 1 days where we had to rationalize the denominator. If you remember, there's some rules that we've had in Algebra 1 along the way. Trying to think, for example, with like negative exponents is kind of like what I would consider a rule, right? You got to move negative exponents either to the top or the bottom. If you had something like that, or if you had something like this, right? That's a negative exponent. That's got to move to the top, and you just get x to the 4th over 1. Okay? So there's some rules like that. Another one that you did both in Algebra 1 and Geometry is if you had something like this, 2 over radical 3. Okay? The issue with this is you can't have a square root in the bottom. Can't have a square root in the denominator. Okay? For a final answer. So what we need to do then is what's called rationalize the denominator. That's what this is called. And if you remember from your Algebra 1 days, all you would do, and I think we did a little bit of this in last section, right? We're just going to take radical 3 times radical 3, and we're going to get 2 times radical 3, which would be 2 radical 3, because you multiply straight across, right? And then on the bottom, you get radical 9, which is just 3, and now you no longer have square root on the bottom. That's called rationalizing the denominator. Okay, so here it's a little different because we have a 1 minus radical 5. It's not just a radical 5. So what we need to do here, what we're going to do is we're going to multiply by the conjugate. Now, you've heard that word conjugate before, right? So if you have 1 minus radical 5, what's its conjugate? 1 plus radical 5. Now the reason we're going to do that I'm going to focus our attention here. Remember, we're going to multiply straight across. I'm going to focus my attention on the denominator, right? We got to get rid of the square root. The reason we multiply by the conjugate, if you look, you have 1 minus radical 5, 1 plus radical 5. I did this problem here, number 6, to kind of lead into the next one, number 7 that I'm doing. 5 plus radical 2, 5 minus radical 2. What happened? We didn't have any square roots in our answer because we had a plus and a minus radical that ended up canceling each other out in the middle, and then in the end you just have a nice neat integer, and that's what's going to happen here on number 7. So down here towards the bottom, I'm just going to rewrite this and do the multiplication. And some of you will get good at this very quickly. 1 times 1 is 1. 1 times radical 5 is radical 5. That's going to be a minus radical 5. And negative radical 5 times radical 5 would be a minus 25, or excuse me, keep getting ahead of myself, minus 5, because it would give you 5 and 5 make 25, and that would give you 5. Middle terms cancel out, so basically you have 1 minus 5, which is just going to be a negative 4. Okay? And so that's what we get on the bottom here. Now we still have to multiply the top out. That's going to give you something a little bit different. So you have 3 times 1 is 3. That's going to be plus 3 radical 5, plus 1 radical 5, plus 5. Put your like terms together. 5 and 3 make 8. 3 radical 5, 1 radical 5, add those, 4 radical 5. So we end up getting 8 plus 4 radical 5. Now, back in your days of simplifying, if this is, all 3 of these are like, have a like factor, like 4, then we need to divide that out or simplify that out. 4 goes into 4 once, 4 goes into 8 twice, 4 goes into 4 once, so we get 2 plus, if you want to put the 1 in front of the radical 5, you can, over negative 1. You can leave your answer like this, or you can run the negative 1 at the top and write negative 2 minus 1 radical 5. It'd be the same exact thing. Okay? So just at the bottom here, I'm just going to give you another situation. I don't even care what the numerator is, but let's say we had 2 plus radical 3, okay? And we want to rationalize the denominator. Go ahead and hit pause and just see what you would multiply the top and the bottom by, and see what you can tell me what that denominator would be. So this would be 2 minus the radical 3, 2 minus the radical 3. Let's just focus on the denominator. So multiplying these together, you're going to see a little pattern start to form when you start to do enough of these. 2 times 2, 4, minus 2 radical 3, right? Plus 2 radical 3, so you know those are going to cancel out. And then you have minus 3. So you end up getting those to cross out, and that becomes just a 1, okay? So that would be your denominator there. So some of you may be able to just see that and know that you're going to square this and basically square your square root, and that's going to give you the number that you have, okay? All right, if you have some questions in class, be happy to help you out. Look forward to seeing you, and we'll talk to you later.